In this video, we'll take a little bit of time to talk about a circle and how we can measure angles in a way that's a little bit different and gives a little bit more detail than maybe you've ever done in the past. So, back in the day, when you first learned about a circle, shortly after, you would have said that there are 360 degrees in a circle. Why 360? Well, several thousand years ago, they used a calendar that had 360 days in it, and they said, why not make the number of portions that we break a circle up into match up with that calendar? Well, they were a little bit off with the calendar. We've adjusted and made things better since then, but we still use the common convention measuring the smaller portions of angles that a circle's broken down into. So we still use 360. It's weird. There are other ways to measure angles in circles that you will eventually learn whenever you're taking a trig course. But for this video, we'll just be using strictly degrees. So we have this circle broken down into 360 degrees. So if you're told that an angle measures 40 degrees, if angle 0 is along the x-axis here, we can think about 40 degrees being a little bit less than half of a 90 degree or a right angle. That makes sense. But what if you wanted more detail than that? What if an angle was supposed to measure 41 degrees? Well, that's obviously just going to be a little bit bigger than the angle that we just talked about. So if I wanted to try to show a 41-degree angle, it might be something like this, right? Just a little bit bigger opening than the 40-degree angle. What if I wanted even more detail than that? Now, this is going to look very similar to what I just erased, but what if we wanted a 41.2-degree angle? So we'd have to open just a little bit further than that one that I just took off of there. So depending on what exactly you're doing with angles, you may need a higher degree of accuracy in certain situations than other situations. So you heard me just say 41.2 degrees. There's another way that we can specify a 41.2 degree angle, and that's going to be the main thing that we discuss throughout the rest of this video here. So 360 is divisible by 60. Uh, we measure time with minutes and seconds. There's 60 minutes in an hour, and there's 60 seconds in a minute. Because we measure time using multiples of 60, and the 360 degrees in a circle is easily able to be divided by 60, one common way to measure really, really detailed or fine values of angles is to use what's called minutes and seconds. So on this screen, we just basically have some notation and some conversion factors that we're going to be talking about here. There are 60 minutes in 1 degree. So just like there's 60 minutes in 1 hour, 1 degree, and think about 1 degree of a circle. That is a tiny, tiny section of a circle. 1 degree of a circle is not that big when you're thinking about a full circle. But if we have that broken up into 60 pieces, that allows us to take that one fine little section of the circle and break it down into a lot of smaller values. Even more so, if we have those 60 minutes within that 1 degree of the circle and we want to break those minutes down into even more detail, we can break them down into seconds. So just like there's 60 seconds in a minute, whenever we're measuring time, there's 60 seconds in a minute whenever we're measuring these small portions of angles. And if you think about it, if we multiply 60 and 60 together to figure out how many seconds there are in 1 degree, it's going to give us 3,600. So over on the right-hand side here in blue, you see some notation being used. You're familiar with this, the symbol for measuring degrees. 1 degree is equal to 60 minutes. So whenever we're measuring minutes, the abbreviation for that, rather than just writing out the word minute like you see right here, is to put an apostrophe after the number of minutes that we're measuring. So here we've been told that 1 minute, using the notation that we just discussed, is equal to 60, and you see that that's a quotation mark, right? Double apostrophe. That's how we abbreviate seconds, right? So minutes is abbreviated with an apostrophe, and then seconds is abbreviated with 2 apostrophes or a quotation mark. So how do we do some converting? So if you look at this particular problem, it asks us to change north latitude 15.735 degrees into minutes and seconds. So a lot of times this notation is abbreviated as DMS notation, degree minute second notation. So we start with just an angle that's measured in decimal notation, and we want to convert it to the appropriate number of degrees, minutes, and seconds. So here's the nice thing. We don't have to touch this piece right here, this 15. This is going to be the whole number of degrees in our new representation of the same angle. So I'm just copying the whole number of degrees into my answer. But what I have to do is I have to figure out what 0.375 degrees is as the appropriate number of minutes and seconds. This 0.375, this is the tenths place, the hundredths place, the thousandths place. So this is a base 10 decimal that we see right here. When we measure with minutes and seconds, we're no longer using base 10. We're dividing by 60 to get those appropriate values for the minutes and seconds. So what we're going to do here is basically just some dimensional analysis. So if you've done some work in chemistry and physics or just any general unit converting, on that previous screen, we had a conversion factor right here, basically. So there's 1 degree equal to 60 minutes. So if I'm trying to figure out what 0.3735 degrees is as the appropriate number of minutes, I'm going to multiply this decimal by a fraction that has degrees in the denominator so that the units of degrees are essentially going to cancel with each other, right? I've got degrees in the numerator here, I've got degrees in the denominator here, and I've got 60 minutes per 1 degree. So when I take 0.375 and I multiply by 60, and that's something you can break out the calculator and do, what you end up with is you end up with 44.1. This right here is the number of minutes that we're going to place after the 15-degree whole number of degrees that we already had as part of that answer. So this 44 minutes came from the portion of this result that's prior to the decimal, but we don't want to, again, use like a base 10 decimal here. This is 44 and 1/10 minutes. We want to convert that 1/10 of a minute into the appropriate number of seconds. And so we do one more little bit of dimensional analysis with that. So again, we're just taking with what's after the decimal here, this 0.1. We want to figure out what 0.1 minutes is as the appropriate number of seconds. So if I take 0.1 minutes and I multiply by the appropriate conversion factor, there's 60 seconds, right? We've got those double quotation marks used there. There's 60 seconds per 1 minute. I'm going to have the units of minutes canceling with each other. If I take 0.1 and I multiply by 60, what I end up with is I end up with 6. I didn't really write that here. It is 6 without anything past the decimal. And so that's the number of seconds that I'm going to put after the 44 minutes. So anytime you're writing an answer measured in DMS notation, degree minute seconds notation, you're always going to start with the number of degrees using the degree symbol, then the number of minutes using the single quote mark, the single, excuse me, not quote mark, a single apostrophe to represent that that's the number of minutes, and then the quotation mark for the number of seconds at the end. So when you're going from the decimal version of degrees to the corresponding number of degrees, minutes, and seconds, this is a valid way to do that. Certain calculators, if you're able to use a calculator, are going to have a built-in conversion as well. But in this case, if your teacher's asking you to measure or do this conversion by hand, then this is an acceptable way to do that. And then the last example that we'll do within this video, we're gonna switch directions. We're gonna start with something measured in degrees, minutes, and seconds, and we're gonna see if we can write the decimal number of degrees from it. So here we start with 39 degrees, 5 minutes, 34 seconds. We want that as a decimal rounded to the nearest thousandth. And so what we're going to do once again is this number does not change. That whole number of degrees is going to copy directly into our answer. So the 39 is going to copy directly in. And then what we need to do is we need to figure out what 5 minutes and 34 seconds equal in terms of a base 10 decimal. And so all I've done here is I've basically used fractions. If you can kind of think of this as a mixed number, it's a weird mixed number, but we've got 39 as the whole portion, and then 5 over 60, right? There's 60 minutes in 1 degree. So this is 5/60ths of a minute represented right here. And then 34 3600ths of a minute represented here, right? Using the last little issue from this conversion factor screen. there's 3,600 seconds in 1 degree. So what I'm basically doing is I'm basically taking this as the fraction 5 over 60, since there are 60 minutes in 1 degree, and this is the fraction 34 over 3,600, since there are 3,600 seconds in 1 degree. So if I take out the calculator and I add these values together, what I end up with is I end up with 0.0927. Well, we want to round that to the nearest thousandth according to this set of directions. So because we see, this third spot past the decimal would be the thousandth spot. Because we see a value above 5 there, we're going to bump that up to a 3. And the decimal that we're going to place after that whole number of degrees is 0.093. So hopefully this has kind of allowed you to understand how to go back and forth between just a decimal version of degrees and to the appropriate number of degrees, minutes, seconds, and then also do the opposite conversion. You'll just have to kind of pay attention to what a problem asks of you. Is it asking for a degree, minute, second angle? Is it asking for a decimal angle? It is definitely more comfortable to see the decimal here because that's what we're used to seeing. This is something that's a little bit new, a little bit different. Certain applications in navigation, engineering might use minutes and seconds a little bit more frequently than decimals. But just kind of pay attention to what your teacher, what your professor is asking you to do with an angle and make sure you represent it appropriately.